So a treadmill manufacturer has developed a new machine with softer tread and better fans than its current model. The manufacturer believes these new features will enable runners to run for longer times than they can on its current machines. To determine whether the desired result is achieved, the manufacturer randomly sampled X number of runners. Our data sets might all look a little different. Each runner was measured for 1 week on the current machine and 1 week on the new machine. The data displays a weekly total number of minutes for each runner on the two types of machines. At the 0.02 level of significance, yours might be different. I think it might be the same though. Can the manufacturer conclude that the new machine has the desired result? So in this scenario, what kind of t-test are we running? Independent or paired? We're doing two independent groups or the same group twice. This is a paired two sample for means. And the reason we know is because it says right here, each runner, so imagine I've got, like all of you are my runners, right? We measured you for 1 week on the current machine and 1 week on the new machine. That means it's the same group of runners twice. So it's paired. And so when we think about it logically, why would the treadmill manufacturer test the same person twice? Well, this will eliminate any other variables that might be affecting it, right? So for instance, a comparable scenario, if let's say I had you run on the current machine and I had my other class run on the new machine, because what happens if my other class that I teach, what if they just happen to be faster runners than you, or with longer stamina, or longer legs, or whatever it is that makes them slightly different from you, right? So it wouldn't make sense. They wouldn't be able to tell the difference between the machines if we use two independent groups. So again, think about the before and after. It's the same group being tested twice. Hence, it's the paired two sample for means. This is similar to in the lecture videos, problem 43 with the ergonomic keyboards, right? We were testing the ergonomic versus the regular keyboards. And again, it's paired. We're testing the same 10 administrative assistants because, well, it wouldn't make sense to have different groups doing it, because what if one group just happened to type faster? That has nothing to do with the keyboards. That's just like their ability to type. So that's the same thing here. We have to test the same group of people twice. Okay, now looking at the story, before we can even touch Excel, because we got to make sure we know which variable is which is going to be our variable 1. So is it going to be our current machine or the new machine? So you want to look at the question. At the 0.02 level of significance, can the manufacturer conclude that the new machine has the desired result? So that is your clue of what is the focus, right? The thing we're testing, the thing we're curious about. So our variable 1 is going to be the new machine, and our variable 2 is whatever's left. That's going to be the current machine. So you want to be careful when you're looking at the homework or in real world or on the exam. What are you being asked? And that's going to be your first variable. Looking at this, what null and alternative hypotheses are you going to be working with? So again, looking at the story, read about the machines. What's the desired result they want? What's so special about this new machine? What's it supposed to help us do? Is this an upper, lower, or two-tailed test based on the story? Right, I'm going to coach you some more. Right here in this statement, the manufacturer believes these new features will enable runners to run for longer times than they can on its current machines. Based on this statement, upper, lower, or two-tailed test? It's upper because the word longer, meaning, hey, I'm running on the machine. Instead of running 20 minutes, I can now run 30 minutes. So this is where the interpretation, right? We're not even talking math. This is just reading comprehension. So we just want to make sure it's like scavenger hunting, looking for clues and interpreting, hey, which direction am I going to go according to this treasure map? So our treasure map here is saying longer times. It's going to be an upper tail test. Go ahead and choose the answer option that is an upper tail, right? So that greater than symbol. Now we'll go ahead and run our data and find our test statistics. So click on our little blue link, click on the little blue box to bring it out into Excel. What you should see, column A is the runners, column B is the current, and column C is the new times. So if it helps to think about it, hey, runner 1, that's Annie. And on the current machine, when I ran for 304 minutes. But then on the new machine, I ran 405 minutes. Right? Can't even spell my own name. So just imagine, these are just a label for the runner to protect their identities. Instead of using names, they're using numbers. So we don't need that for our analyses. We simply need the current and the new. We want to make sure we put them in the right order. So go ahead and open up your data analysis tool pack, and we'll go ahead and pick paired to sample for means. And again, paired is as in like a pair of socks. So here's Annie's pair of run times on the 2 machines. We're going to be using paired. I'll go ahead and hit OK. And double check, go ahead and look at your test. Does it say T test paired to sample for means? Now remember, our variable 1 and 2 matters the order. And so we had discussed that because the question was, hey, are the new machines doing what we want it to do? That means our first variable is the column for new machines. It's not just reading left to right. It is based on the story. So our variable 1, we're going to go ahead carefully, highlight, including the label. I click on the word new, and then I carefully highlight down all my numbers. Yep, goes to 36 row or 35 values. So that's going to be my variable 1. And then go ahead and do the same thing for variable 2, but now that's going to be our current. So our current data in column B is our variable 2. So go ahead and plug in the 0 for our mean difference, check labels, and then I don't know if you've got a slightly different alpha. I'm just double checking. Yep, my alpha is 0.02. So I'll go ahead and type in 0.02. And whenever you're ready, go ahead and hit OK. So again, we're double checking. Yep, I am doing the right test. It's a paired to sample for means. My new machine came first, and my current machine came second. My observations for me, I know I was working with 35 runners, so I want to double check. When there's an error, sometimes it's because we missed a row, and you'll see a different number here versus the story. So just double check that. And let's go ahead and find that test statistic then. So look for your t-stat and plug in, depending how many decimals, in this case 2. I'll go ahead and use my handy just to help me out a little bit. Everyone get a test statistic okay? So again, very important, double check, right? We were doing an upper tail test. That means we're on the positive side. That means your test statistic should be positive. If you were in a lower tail test, you would expect all of your numbers to be negative, right? So just again, remembering that concepts with our normal distribution, right side is positive, left side is negative. Again, looking at our Excel, in this case, we're doing an upper tail test, so it's a 1 tail. So then you'll just want to make sure in your Excel file, look for the 1 tail p-value. This one right here, P for p-value, 1 tail, because it's an upper tail, and it's going to be whatever your number is in that box. So I will go ahead and plug mine in. And so based on your p-value, you'll want to compare that to your alpha and make a decision. So this is where carefully looking at the numbers and not rushing through and making sure we understand, hey, my p-value is blank to the alpha. So my decision is blank. So for instance, on mine, my p-value of 0.146, that is larger than my level of significance of 0.02. That means it does not fit in the rejection region. It is bigger. So I am not going to reject the null because I don't have enough evidence that the new machine is doing what I was hoping it would do, which is let us run for longer times. And you live through this. Okay, so just kind of a reminder, we've got the Excel file open. If you were asked to do the critical value approach, let me just highlight. again, this is a one-tailed test. So that means I would be looking at this right here. This is my critical value. And I would compare it to the test statistic, right? So I draw my critical value, and I take my test statistic and I see where it falls. Did it fall in the rejection region or not, right? So if you're asked to analyze it that way, just be ready to imagine where your critical value is. Where's that cutoff point? And then where does my test statistic fall? Does it go past the critical value? So does 1.06 or 07 go past my critical value 2.1? Hopefully you think no. Fantastic. Thanks, Hannah. It does not go past. That means we do not reject the null. And just like the p-value approach, we didn't reject the null, at least in my scenario, because it wasn't smaller than the alpha. So if you're asked for the critical value approach, that's all you're doing is you're just going to compare the applicable critical value to the test statistic. Now, in the examples that we've been doing so far, they were upper tails, so our test statistics and our critical values would be positive. If we were doing a lower tail negative scenario, then your test statistic would have a negative sign in front of it, right? So it would say negative. But here's the thing, in Excel, it doesn't know what kind of tail you're doing. And so it would give you the the critical value like this. You have to remember, hey, I'm doing a lower tail test. This critical value is really negative. So you have to remember to put in the negative symbol when you're working with critical values. But the same goes for a two-tail test, right? This two-tail, you see this number, you know it's plus or minus 2.44. So just be aware that Excel is limited because it doesn't know what your story is about, lower, upper, two-tail. So it's just giving you all the information it can come up with, and then you got to fill in the blanks.